Hello guys, Nigel here, Nigel's Land Rover channel, and this is part 3 now, and you may detect a little bit of a sort of down note in my voice. The main reason is I'm filming this after everything else you're about to see. The battery went on my iPhone 6, so I used my iPhone 10 to do some filming, and maybe someone can tell me in the comments below why this happened. I filmed this, what I'm doing now, on my iPhone 10, and then the next part, uploaded it onto my computer, and then realised that it only kept about 30 seconds, and the rest of the length of the video was just me like this. So why would it do that? I don't know. The iPhone 10, I think, compared to this iPhone 6, is a piece of junk. I can't stand the bloody thing. Its Wi-Fi reception isn't as good. I don't like the camera, I don't like the face recognition bit. That is total garbage, I think. And because, like, you know, you're sat there, you got your phone next to you, just want to see if you've had any messages, you know, you just touch the screen. That bloody thing, you've got to actually look at it, you know, rather than stupid bloody thing. So yeah, if anybody knows why it does that, it looks like it's filming, but it actually only records about 20 seconds worth. So weird. So part 3 is all about, as you can see here in the side of the shot, this is the intermediate gear from the transfer case, and it's been quite a discovery, this one. I mentioned to you before that I know that this bearing has been spinning. It's spun on the shaft, and I can see marking in the transfer case housing that I'll show you in a minute, and you can see where it's spun in there. So clearly the nut wasn't tightened up enough. And I'll also show you that later in the video on my theory of why that is. It's a little bit difficult to show you, and it's a little bit difficult to explain, but those that know these things inside out will know exactly where I'm coming from and hopefully give me some advice. The other thing that was very shocking was I was expecting to take this apart and find that the actual gear cluster itself had 2 big circlips in it that the bearings sit on, and then in between there was a collapsible spacer. And the way you set it up then is you just do the nut up until you get no end float, and then you set it, the manual tells you to set it up with a torque wrench, pounds-inch torque wrench, and you actually just add a little bit more torque to what you can feel through the input shaft. So that's how you set your preload. No, not this one. This is out of a 2011 TDCi, as I'm sure you all know by now. It has recesses machined in the gear, in the hub, as I think I explain later, and it has a spacer sleeve. So really weird. So obviously all they've got to do is put it together and torque the nut up. So they've obviously made assembly easier, but the person that built this messed up big time. And watch the next few minutes of this video and you'll see why. Right, here we are with the transfer case in the kitchen, and as you can see, when you look down in here on this bearing race, well, this is the inside face of the transfer case, if you like, where the shaft goes through. So we've got a hole on the other side there, so it goes straight through there. And as I said earlier, it's not bolted. So this is where the bearing pulls up, and you can see on there, if we look closely, can you see on there? I don't know if you can make it out, but the bearing is actually spun. So there was obviously not enough clamping force holding that bearing in place. Okay, this video is a bit bitty, I'm afraid, guys, because I'm having to do a lot of editing, because I'm discovering stuff after I've said something and I've discovered I'm wrong. This is totally foreign to me, and it probably totally foreign to most of you guys too. If you look in here, normally there are circlips in this gear that support the bearings. And in here there's machined recesses in the actual gear to accept the bearings, so there's no circlips. And then what you do, as you look in the manual, you get a crush sleeve, a collapsible spacer that goes in. This is a solid spacer, it's not collapsible. So basically this has been designed so that you put the one bearing in, put your spacer in, put the gear on. Imagine this is in the transfer box now. Put the bearing on, in your transfer box, put this on, and then torque the nut up. And that will pull those bearings into that spacer, and if the spacer is correct, you'll get the correct amount of preload. Now I'm going to see how much preload I've got. What I've got is some bits of shim here, which they're bits of old 4th feeler gauge. So they're totaling 8 thou. So I'm going to put them between the crush washer, or between the spacer and the bearing, the inner bearing. And then when I clamp it all up, I'll see how much movement I've got, and we'll see how much preload I've got. But basically, this is a real mystery because it's totally different from anything I've seen on YouTube, any manuals or whatever. I've actually emailed Dave Ashcroft and asked what's going on, because obviously this nut is supposed to be torqued up. The failure mode on mine, where the bearing is spun, I can only think what's happened is, if you look at this damage on here, let me get it on the camera so you can see it. You can see that damage in there, and that sits on that flat. So when that was put in there, because this thread was so tight, I mean, it must have been 30 Newton meters just screwing it onto the thread, even more probably. So what's happened is, I think in the factory what they've done is just basically tighten this shaft against this spacer. So all of the load was between here and here. So there's been no load put on these bearings at all. So I'm sure that's what's happened. So what I'm going to do, I'm going to build it into the transfer box, get that to jam on there, and I can see where the nut's been turned because you can see where the where it's been staked. So we'll see what it looks like when you put it together properly, but with the nut at the same place. But first of all, let's have a look at the envelope. Right, using the same theory as I had before, 8 thou shim in there, between the crush sleeve, or the sleeve in the centre, and the 2 bearings. So it's actually pushing the 2 inner races apart. And then what I can do is use this to measure, use this clock mounted on the gear to measure the amount of end flow. And then whatever I get from that, subtract that from 8, and that'll give me how much preload I've got. So let me get the camera up closer so I can show you exactly what I've done. Alright, so I've brought you in closer so you can see what I'm talking about here. But basically what I've got is the shaft is as you know on these spacers. So basically it's held now, there was 8 thou shims. Okay, the clock is reading 0. So that's with the weight of the gear down on the bearing. So I push down and the clock's reading 0. Now when I lift up, the shaft will fall away. I give it a little push down, and you can see it's about 5.5, 6 thou I'm getting. So that means with the 8 thou of shims, I'm getting 5.5 to 6 thou of movement. So I've got sort of roughly 2.5 thou of preload on those bearings, which is fine. So what went wrong? Right, so I've got the gear back in the, here's the gear in the transfer box there, and it's sat on the bearings, and I've got the dummy here, okay, and I've got just a scrap bolt in there. This is what I've discovered. I'm going to zoom you in to show you this, and this is where I'm going to say a big thanks to whoever built this transfer box. Thanks ever so much. Right, imagine now that this thread is really tight as it was, and when I screw this nut on, it's taking loads of torque to turn the nut. So it's going to turn the shaft clockwise as I wind the nut on. It's probably done with an air gun or something, so they don't know what's going on. And the plate's there and it's bolted to the transfer box. Look at this now. Okay, if I turn this, I'm turning that shaft anti-clockwise. I can push that through, okay, and the plate isn't moving at all. Now if I undo the plate, you can see I can push the shaft forward and backwards without moving the plate. Now, as I say, this thread's tight, so I'm winding the nut on really tight, and it's crunching that shaft around until it's on the edge of the flat. Look now, when I push the shaft back, when I push the shaft out, it's pushing the plate with it. Okay, that's where that plate's grunched. So all they've done when they've torqued this nut up, what they've done is actually pulled the plate into the shaft rather than pulling the, there we go, I can tighten that nut up there and I've still got a gap. So that's how my gearbox has been running. So let's do it properly and see what happens. So take this nut out, do this bolt up on the bottom of here. You can see there that plate is stopping that coming right through, because if I turn it now anti-clockwise, if you look, I can push it through further. There you go. Look at where it is there. See that? If I turn it, that's how far it comes through. I can't push it through anymore. So turn it back and then it comes through. So that's how it should be. And then because I've dealt with the thread rather than just bodge it all together like they did, I can actually, when I do this nut up to where it was, and we should find okay, I can go almost where it was. So now that's got a lovely bit of preload on it. Obviously it's going to be a bit noisy because the bearings are dry. So now it's right. Let's try it as it was before. This nut is becoming damaged because it's been on and off so many times. I've got a new one to go on there, so not to worry. So then push that back in. Should undo this. Give it some float. Okay, so that's how they had it. Let's turn itself back. That's how they had it, like that. So when I wind this nut on, it's all free. Yeah, it's pulled it through, but I'm convinced that's what it was, and the torque they've used has all been used up in the friction of launching all that together rather than actually loading into the bearings. So what do you think, guys? Should I get new bearings and shaft? Let me know in the comments below. Thanks for watching. In the meantime, I can go on and get the diff built up and everything, because this is actually the last part that goes in the transfer case anyway. So yeah, in the meantime, we'll do part 4, which will be actually building up the diff, and I'll see you then.